Alright, October 15th. Alright, let's see. Longest happy string. We're gonna be happy. S is happy if it satisfies the following conditions. Only contains the letter A, B, and C. Does not contain any of these as substring. Contains at most A occurrences of letter A and B and C. Okay, so basically it's going to be a string that contains A, B, C, and we'll have at most this number of A, this number of B, this number of C, and now we cannot have triplets of A, B, and C. Given 3 integers, return the longest possible happy string. If there are multiple, return any one of them. If there is no, return the empty string. Okay, so in this case, A, B, longest possible. Yeah, if it's smaller than 3, then you can just put all of them in there. And it doesn't matter. So what matters is whenever this one is large. So C is 7, and then we say we cannot have all 3, so it has to be a CC. We have to skip, right? A CC, skip, a CC, and a skip, a C. This is what we 1, 2, 3, 4, 5, 6, 7. Right, this is a 7, and we can put A, so we can put A here, or put a B here, but there's nothing else, so we cannot do this. So that's why it's gonna be CCA, CCB, CC, right? In this case, it's the same because we can only have one in between. Okay, so what do you think? We can, and they only need to be separate by 1. So we shall save. I mean, we can pick the longest one, right? Pick the maximum of ABC and then do this scheme. All right, pick the longest, so we do this scheme. And then for this, do we put 2 or do we put 1? Well, we can put the second longest in between this, right? And once you're done, then we have some left, and then we do the, yeah, I think that seems to be the best strategy. The longest one, we do this scheme, and then we have these things in between, and we have 2 more to fill. And if we choose the lowest count, and if we fill it in, then the remaining second longest, basically we don't have any separator, right? So instead, we get the second count, try to fill as much as we can. If we fill it all, that's fine, and then we fill whatever the smallest. If we don't fill it all, then we fill it as much as we can, right? And then we'll have the remaining 2. We pick the longest one, and we'll use that to do this, right? Use that to get the pattern. And okay, so the strategy, we have a strategy. Now we just need to implement it. How do we implement it? Well, we implement it by, I think, picking 2 out. We can do a string, right? And then we do another thing, and we concatenate those. So kind of make the logic a little bit easier. So basically, we're gonna say we'll have a function. Let's call it. We'll have a function. Make string int. Oof. We also need to know it's A or B. Oh my goodness. So char x int x count, char y int y count. So I can say x count larger equal to y count. Okay, so now what we're gonna do is, oh, hold a second. No, yeah, I don't think so. I think we have to go through this. So first of all, we need to sort them, right, based on who is the largest. Who is the largest? So we're gonna do char array, letters, it works that way? And now we say arrays dot sort letters. Dude, this is not gonna work. This is not gonna work. Hold on. I don't think so. Let's do this. We can say A. All right. Okay, so we will sort this and we say A, B. Well, integer dot compare A1, B1. I want it to be reverse order, so I do. If I want to be reverse order, so I do this. Okay. So now I have the letters. So the first one, and we can say char res new char a plus b plus c. All right, this is the maximum possible. And then for the longest one, we're just gonna do 2 skip, 2 skip, and 2 skip. Okay, so for int I equal to 0, I smaller than res.length, I plus equal to plus 1 plus equal to 3. So 0, 1, 2, 3, right? And what do we do is my letters and letters 0, 0 is larger than 0. Okay, so what do we do is res I equal to letters 0, 0. Okay, so this is not 0, this should be 1. Res I plus 1 equals letters 0, 0. Okay, and then we skip. So keep doing this until we finish. Right, until we finish. And also, actually, yeah, actually this is not necessary because I can do it here. Letters 0. Let's just do I++. I have a better idea. If I mod 3 is smaller than 2, okay, then we'll do this and do letters 0, 1, minus, minus. Then I can do it here. Yep. Letters 0, 1 is larger than 0. Okay, so I can do this. Yeah, if it's smaller than 2, so it'll be 0. We put it, and then yeah. So once this is done, right? Once this is done, we will fit. All right. So now I have. Yeah, you know what? I don't think so. I think we should analyze. Right? We should analyze. So I have the maximum, so I get how many it is. Then we can do that divided by 3. Right? So that divided by 3 will tell us how many intermediates do we need. Yeah, the divided by 3 will tell us how many intermediates we need. Then we check. You know what? Yeah, I don't think this is the right way. Don't think so, but we probably can still keep this, right? So step 1, find how many gaps we need to fulfill. Right, to fulfill all step 1, fill the max count letter. Okay, then int gaps shall equal to letters 0, 0 divided by 3. Right, letters 0, 0 divided by 3. Okay, that's good. And depending on how, hold on, still. Is there like a more computer science way to do this? I feel like I can do it, but it feels wrong to me. Can we just get the most count? And then get the second most count. Most count and the second most count. So most count. No, I don't think that would be a good idea. What's wrong with rotating them? Just goes like ABC, ABC, ABC. Well, because you're wasting. Right? You're wasting. Because A, you can get 2. That's why the maximum you can get 2. Alright, you get 2. And then you hit a gap. You hit the second largest one. You hit a gap. And you go back to the first. You hit 2. And then yeah. If it feels like I want to find a like easier way to do this. So by doing this, I know the gaps, right? I know the gaps, and the possibility is the second. If the second is bigger than that, then we can fill all the gaps, and I'll deal with it by itself. But then that's kind of another question. So we need a question if we have 2, right? If you have 2, how do you handle it? Yes, if you have 2, it's pretty straightforward how you handle it. You get a bigger one. Oh, actually no. If you have 2, then if you have 5, yeah, that's actually not right. What if you have 5 and 5? Right? You can say A, B. Okay, that's a bad example. Oh, okay, that's actually fine. Or how about for everyone, I just get A, B, C, because when it's doubles, as long as they don't meet each other, it's fine, right? So basically create, let's say we call it a big A's, right? And then we always have either all of them or we have a little A left. All of B's, so we have a little B. All of C's, we may have a little C. Or we not, right? And then they can just A, B, C, it doesn't matter. But if we have a lot of A's, right? If I have a lot of A's, then you do A, B, and that's the thing, right? That's the thing. You have the longest, you need to use these more economically. So yeah, I do think it should still be, you find the gaps, right? And should try to fill the gaps individually. And there are 2 scenarios. The first scenario is, and if we only have 2 left, okay, then it does not matter how you do it. Because actually it does matter how you do it. Because I can have A, and A, B. I can have 6 A's and 2 B's and it still works. So we still have to run this again, but it'll be easy to run. So now we have the gaps, right? So scenario 1 is the second largest can fill all of them, right? So second largest can fill all of them. Then we go for the third scenario, and the second largest can fill all of them. And the second scenario, the second largest cannot fill all of them. Then we have something left, right? We have something left, and when we have something left, then the third filled in, right? The third filled in. Yeah, I think that's the only 2 scenarios, right? So I'm going to say if gaps is larger equal, no, smaller equal to letters 1, count is at 1, right? Is smaller equal to this. So this is fill the second max count letter, right? Then hold on, the second can fill all the gaps, right? Then we shall say depends on who has more. Then we say letters 1 minus equal to gaps, right? Minus the gaps. Now we say if letters 1 Yeah, that's the thing. If you have 6 and 6, right? If you have 6 and 6, if I do this, then it will fail, right? It will fail. So actually, yeah, actually, this is a good way to figure out. So the smallest difference, right? So the maximum one divided by 3 that we have for the minimum. If the minimum one cannot fill the gaps, right? If the minimum one cannot fill all the gaps, then we will only get however many the minimum one can fill. If the minimum one can fill the gaps, right? It can fill the gaps and we have extra. Then we have 1 extra is fine, 2 extra. Like if we can have as many as the same number of extras because we can always put it in there. So the max capacity, yeah, we can actually try to find the max capacity. So we'll have the 2, the 2, the 2, and then we might have a 1, and then we have these gaps will be. So the max capacity is the gaps are, like max capacity is the gaps, each has 2, and then we have 2 more at the end, right? That's the maximum capacity. Yep, that's the maximum capacity. And we should always just stick 2 in it. I cannot always stick 2 in it. It depends. Because if we always stick 2 in it, like we might lose. Okay, so we're gonna do another round of analysis here, right? Okay, this is harder. This is actually easier, right? This is actually easier. This is the second max count cannot fill all the gaps. Then depends on if, right, gaps minus letters 1, 1. If this is smaller or equal to letters 2, 1, right? This is the third max count can fill all the gaps. Else, the third max count cannot fill all the gaps. This is the easiest one. The third also cannot fill all the gaps. Then we'll have a scheme, which is 2 of the max, 1 of this, 2 of the max, 1 of this, 2 of the max, 1 of this. And then if it's done, we move on to the second one. And until it's done, and then we get 2 of the max. Yeah, I think we can fill this. We need I is 0. I is 0. Yeah. So k smaller than, no, not k smaller than, it should be k smaller than. No. Should be letters. J should be 1. Letters J. I don't need J. I just need one of them. So letters I 0. Now I no is larger than 0. K plus plus. Yeah, I don't see why it's so hard to understand. We already figured out how this one's gonna go. Right? We already figured out. It's just implementation. If I mod 3 is smaller than 2, res I equal to letters 0, 0. Okay. Else, if letters 1 is larger than 0, res I equal to letters 1, 0. And then letters 1, 1, minus, minus. Else, res I to letters 2, 0. Okay. And letters 2, 1, minus, minus. Yeah, so you okay, I think this have to be this or the other one. Say letters 1 is larger than 0, or one of them is larger than 0, and then we can keep going, right? Okay, now we get out. I think we can probably just return. We can say res.toString. Right, I think this is how char works. Actually, we can try this. Char equals to new char A, B, C. Actually, char foo. Can say maybe 10. Oh, Okay, yeah, that's right. I say char and foo 0 is, I don't know, it's to A, foo 1 is B, and I'll say foo dot to string. Oh, string, oh, I forgot. How do I do that? Char array to string. String the value of ah, that is bonkers. Oh, I do not like that. Okay. Okay, how about this? Arrays dot fill. We fill it with, let's say, this. Empty character literal. You cannot even do that. Wow. Okay, this is kind of stupid. I don't like it anymore. Do not like it anymore. Okay, so maybe we don't do it this way. Maybe we say string builder. Okay. And then we, instead of doing this, we just say then why do you need to do all the analysis if you do string builder? We just do the maximum, right? Maximum, and then we hit second maximum, second maximum. Or I just realized maybe we should alternating. Right? It should be whoever is maximum should offer it. I see a new scheme. So we do the maximum, so 2 maximum, and I will do the max of the remainder. 2 maximum. Hold on. Maybe we should every single time we'll get a maximum pop out. Right? Actually, I'm not sure. I am not sure. So now you're thinking about a new scheme. Right? I'm thinking about a new scheme, which is if you have a max heap, right? You have the maximum count 1 so far, okay? And you will get 2 of it out, right? This is maximum count, we get 2 out. And then you search for, but you need a second maximum, right? Okay, so you get 2 out, and you have to have another one. So you get 2 out, so you pop it out. So the remaining 2, you find a big one, you push it in, and you push the other thing back in, right? Then you pop the next 2 out. Then how do you guarantee the next one will be the same? It will be different, right? Hold on, let me let me think it through. I need to think it through. Because I want to find like a universal method for this. So you have the maximum count, right? Something maximum count, and then you pick 2 out, right? And if it's still the maximum, that's fine. And if it's not the maximum, so you always get it out, right? And then the remainder 2, you pick 1 from the maximum. Will that still be the maximum if you put the original back in? Well, if it's still the maximum, that means the original, so let's say the 3 is the same. So pick 2, right? This one is down. And the second maximum, you pick 1. and the third maximum. So, okay, how about this? If it happens that after you pick 2, the next one in line is always big, and then if you pick 2, okay, you take it out, next in line you put 1, you basically you pop it, then you get 1, and you push both in, right? And the next the top, you just check if it's the same, right? If it's the same, you will pop that one and use the second one, put 2 in, right? The second one you put 2 in, and then you push. Would that work? Will that work? I mean, it's better than your. I mean, you try to analyze it at the moment, and you haven't even figured out the first one of them. But it won't solve the problem, right? Like 6 and 6. So you get 2 out, you get 1. Then you get 2 out, you get 1. Then you get 2 out, you have 4 left. Then that won't work. So you do have to analyze it, man. I think at the end of the day, I still have to. I don't know, man. Right now, I feel like you just have to analyze. All right. Anyways, if we do analyze in this way, so rest. In this case, rest dot append letters 0 and 0. Okay. Right, that's the first one, and then yeah, this is fine. And then we'll do this one the same. So this is also dot append this, right? And this is the same. Man, full on analysis. I'm not sure how I feel about that. Okay, so we do that, and then once it's done, or yep, it's fine, so we just append this, or append this if it has, and then we'll append that. And once we get out, then we can append, maybe 2 more, depending on how many A's we have, right? How many the first letters we have. Oh, then we have to also say letters 0, 1. No, also minus. Okay. So now we get out. I 0, I smaller than 2, or letters 0, 1 is larger than 0, I plus plus, and we'll do rest dot append letters 0, 0, and letters 0, 1 minus. So this guarantee will get at most 2, right? At most 2, or whenever it extends. Okay, so that's the third situation done. Now we have to go back to the previous situation. So we have, this situation. The second mask cannot fill, right? The second mask cannot fill. And the third max can fill all the gaps. So this situation is the third max can fill all the gaps. Second max cannot fill, so I can actually do that. And the third max can fill all the gaps, which means I think I can copy and paste this entire thing. Right, I can copy and paste this entire thing, but we need to do a little bit tweak. Alright, so we're gonna tweak this a little bit. So this is the saying, we do this, but it's a third can fill all the gaps. But the first, so the gaps minus this, minus the second one, and we have some third one left, right? So we have some third one left. But is that the best use? Is that the best use? The second cannot fill, but the third one can. Right, so we have third one and can fill some, and I have some leftovers. But those leftover, you might have a better way of using those. Let me think. Wow, this is harder than I had thought. Yeah, but then we hit a problem because you have two left, and when you have two left, the situation is different. Man, I need to think about something else. I feel like it's, maybe it's DP, because I feel I'm trying to analyze this, but I just can't. I can't analyze it. Because if we do DP, okay, we can say DP. Because each position you can have three choices, right? Each position can have three choices. So we can say, okay, if I choose this, I choose A, okay? Or I can choose B, or I can choose C. And if I choose A, right, then the state, what is the state? The state is the remaining of the three, right? That is your state. So we can say when they're starting from a position, right? Starting from a position, and with A is this, then you're talking about a four-dimensional. I am not sure if that is the way. It is like four-dimensional. Yeah, we start from 0. Remaining A, remaining B, remaining C. Okay, so I have a 0 position, and I say, okay, we'll do it A. Okay, and then we pass into the next one. One position we can do A, right? Well, we need to see the previous position, what the previous position is. Backtracking. Backtracking. So we have A, and then we say we do A, and then we say we do B, and then if it doesn't work, backtrack. What do you mean by backtrack? Like every position we try 3. Now we're trying all different combinations. I might time out on this though. All different combinations. So you always try A first, and A doesn't work. Then you try B, then you try A, right? And then you try A again, and then you try B, right? And then after you do that, you say, okay, how about I try C? And then you go back to try A. I don't know, this feels, I mean, this will work, right? This will work, but all right, I have to go train. This is yeah, I'll come back to this. I'll see you guys later. Adios.